Hi everyone. Now in this video I explains the physical and logical data flow diagrams. Okay. So if you take the data flow diagrams, it can be a physical system model or a logical system model, or it can be a blend of the two models, physical and logical, right? Now in a physical data flow diagram, uh, so we usually include the implementation technology, right? Now remember, usually in data flow diagrams, we make a perfect internal technology assumptions. So what do you mean by perfect technology assumption means? So we assume that the technology capabilities such as instant processing is done by the system, and then data retrieval has been done by the system without having any issue, right? And then we have infinite storage spaces, and we have infinite network capacity, right? And basically the process will carry out without having any errors. So that's what they mean by the perfect internal technology means. So the physical data flow diagrams basically assume that uh, there is an implementation technology reflected in the data flow diagram, right? So these assumptions can take actually many forms and might be very difficult to spot in a data flow diagram, okay? But when it comes to the logical data flow diagram, so usually logical data flow diagrams are drawn as if the system might be implemented with any technology, right? So in fact, one way that business analysts develop the logical data flow diagrams is to assume that the system is implemented with perfect internal technology, right? Uh, Now, as I mentioned before, perfect internal technology means we actually assume processes never make mistakes, data entities can hold infinite amount of data without losing them, right? Data flows and processes with infinite capacity, and zero execution and transmission time of the data, right? So the business analyst simply omits any system features that wouldn't exist under the perfect internal technology assumption when they construct data flow diagram. Okay. Now in this page you can see there are two data flow diagrams. In my left hand side, I would say this is a logical model or logical data flow diagram. Okay. Why it is a logical data flow diagram? Because it is not so clear what type of computer is doing these processes, isn't it? Right? It can be a desktop system, it can be a tablet system, or it can be a phone app that runs these processes. So even it can be a cloud computing solution, right? Or even you can say, okay, entire these processes, all these processes can be carried out by the people without any compute at all, right? And also these data stores, right, can be a sequential computer files, right? It can be a relational database files, right? Or maybe it can be a paper-based files in the cabinet, right? uh, and also we don't have a kind of any idea now here the customer is sending the new order, right? So so how does the system get the data flow, this new order from the customer, so it can be processed, right? Is it clear here? No, it's not so clear, right? So it can be customer can be clicking the check boxes and list boxes in the Windows application, or it can be a web page that customer input all these information, right? Or it can be a manually filling out a kind of a form that the later other staff can be scanned into the system, or they can actually talk to the clerk over the phone, or they can visit the store and give the order details, right? Or even they can talk into a speech recognition program over the phone, right? So this anything can be possible this in this new order details, right? So so that's this kind of model is called actually a logical model. So we can't actually tell how the system is implemented, right? So at the same time, the processing requirements, that means what must go on, right, should be fairly detailed. So we can see in here what kind of processes are there, right, and what information is flows right between the process. So it's fairly detailed, and even we can describe these processes in using data dictionary items, right? Creating data dictionary items like process descriptions, data flow description, element description. So we can go into such detail, right? So this kind of model is called a logical model. Okay. Now compare this with this model in my right hand side. So in this model, I would say this is a physical model, right? So the elements in this model actually indicate there are some assumptions about implementing technology, right? So we can say there are some technology specific processes, actor specific processes by process names, and technology or actor specific process orders, right? Ordering the process based on the technology or actor based, and even sometimes redundant processes or redundant data flows and the files you can see in this model, right? So if you think about process number 1.1 here, obviously this assumes a technology that we implement this process, right? Now what is the technology? Make copies of department chairs means, now here you can say this is a scheduling course system. So make copies for department chair, it's obviously a human process, right? It inherently a manual task, right? So that means whatever the information comes from here is sort of it looks like a paper-based information, right? So it is possible that the data store and the data flows are electronic, but sometimes we can question if it is electronic, then why we need to make multiple copies, electronic copies of the schedule or class schedule, right? And also you can notice that many of the process names include actors in the system, or we can say the external agents in the system, right? So we can say some processes named like chair, right, or associate dean, right, and the university scheduling, etc., etc. Uh, so it actually indicate which actor is performing which tasks, right? And also it actually tells a sequential flow of data among the processes, right? um, so sometimes we can say, okay, the alternative approach is Okay, we can have fewer processes because there are some processes are kind of redundant, right? For example, here the feedback, now chair here incorporating the faculty preferences, and here also dean incorporating more feedback. And so this looks like a redundant process. So why we need the redundant processes, right? Because this actually reflect the human nature of or human technology or manual task of or how it flows through in the system, right? Uh, so so this is called the logical model. So this is called left hand side called the logical model and the right hand side model called the physical model, right? So very inexperienced business analyst often develop data flow diagrams like this in logic in physical models, right? Um so this is not what we need actually at the analysis stage. We need the logical model because we want to do depart from um, physical aspect of the system, right? So we need the how the information flows through the system rather than the physical attributes. Okay, so that's the distinction between the physical and logical DFT. So please make sure at now remember in this unit, this particular requirement analysis and modeling unit, we are focusing on the logical or requirements, right? Not the how we physically implement the system. Design stage, now this is a design stage activity, right? So we are not actually consider this at requirement analysis stage. Okay, so in your diagrams, make sure that you don't reflect the physical aspects in your requirement models. We need to actually consider only the logical aspects.